unit, our test is very similar to our quizzes. So let me review the whole thing. The first few questions is asking me if they're similar or not. For my figures to be similar, my angles have to be the same. I don't think I have the same picture as you guys. Let me fix this. Alright, my angles have to be the same. And I notice they're all 90 degrees, so it's good. My angles do repeat. Now my sides have to be proportional. So I notice that on one of my sides, my numbers are 10 and 14. So I do 10 and 14. For the other one, my sides are 4 and 5. So I go forward, smaller than 5. So if they're proportional, I can just cross multiply. It should be the same thing. Or to make it easier, I can simplify first. 10 over 4 is 5 over 2. 14 over 5 is not 5 over 2. So I know they're not proportional. So I'm going to say not similar. Remember, my figures to be similar, my angles have to be the same in both figures, but then my sides have to be proportional. So not similar. Any questions for the first four? All right, looking at question number 5.
Wait, number 2, I'm sorry.
Number 2. Okay, I know that in a parallelogram, two adjacent angles have to add up to 180. So one of them is 110. I know the other angle has to be 70. Right, because they have to add up to 180. So angles-wise, I notice that my angles do repeat. Right, my angles are the same. Now for sides, the measurements of one figure is 12 and 12. The measurements on the other figure are 4 and 4. Right, I don't have to simplify, but we can tell they're proportional, right? If I cross multiply, I get the same thing. So I'm going to call this similar.
Just because like of the degree, I thought they were different, so yeah.
Okay, so cool. Any questions on the first 4?
How did we get 70?
I know in the parallelogram, two adjacent angles have to add up to 180. So one of them is 110, the other one is obviously 7. All right, now let's take a look at number 5. Instructions say the polygons in each pair are similar. So because they are similar, I know they're proportional. So from one of my figures, I have the numbers 6 and 10. So I'm going to write 6 is smaller than 10. From the other figure, I see 3 and x. I know 3 is smaller than x. We can cross multiply and solve for x, but let me simplify first. 6 over 3, let me call that 2 over 1. We can cross multiply from here if you wish, but let me simplify even more. Sideways, 2 and 10, they become 1 and 5. So now when I cross multiply, x equals what?
5.
X equals 5. Do another one? Number 6. All right, let me take a look at number 6. I have three numbers on each figure, but in reality I only need 2. All right, so I have an extra number there. So from one of my figures, I'm going to use the numbers x and 14. Now my question to you is, which one's smaller, x or 14? 14 is smaller? X is smaller? If you're not quite sure, measure it. Right, you can use the edge of a paper, and I'll tell you guys x will be small. So x is smaller than 14. Like if you're not quite sure, bless you. You can use the edge of a paper as a ruler to be able to measure it. Now on the other side, my numbers are 6 and 7. I think we can say that 6 is smaller than 7. Right? We can agree on that. 14 over 7, let me simplify that as 2 over 1. I know 2 and 6 can be divided each by 2, But I cannot simplify diagonal, so I'm not going to simplify it. X equals what?
12.
X equals 12. Good.
So if there's like three numbers, you only need to take two.
You only need two. Right? Because we know that they're all similar, they're all proportional. So just get two. Now, something very similar is in question number 9. The next section is the same idea. The only thing is, where the x is, there's going to be a plus or minus. So it's not going to be that simple. I'm just going to add a plus or minus right where the x is. So from one of my figures, I have 16 and 5x minus 2. I think we can agree 16 is smaller, right? So I'm going to write 16 is smaller than 5x minus 2. For the other measurements, I have 20 and 35. We know 20 is smaller than 35. We can cross multiply. Just whenever you cross multiply, when we have a plus or minus in there, make sure, if I cross multiply right now, make sure that 20, you multiply to the 5 and to the 2. So I say make sure you multiply to both. But before I cross multiply, I'm going to simplify. 16 over 20, let me call that 4 over 5. I can also simplify sideways. 5 and 35, let me call those 1 and 7. So now when I cross multiply, make sure you multiply the 1 to both. So I get 5x minus 2. On the other way, I get 28. Right, I'm just cross multiplying. The rest is just algebra. If 5x minus 2 equals 28, what's x?
X equals 6.
X equals 6. Any questions up until 12?
10.
Number 10. All right, looking at number 10, I have more than two sides for figure. I'm going to get, in one side, I'm going to get 5x plus 2, 5x plus 8, and 42. The corresponding sides on the other figure are 40 and 35. I only need two per figure. So from the figure at the left, I'm going to write 35 is smaller than 40. From the figure at the right, I'm going to say that 42 is smaller than 5x plus 8. Then I'm going to simplify. 75 over 42, let me call that 5 over 6. I can also simplify sideways. 5 and 40, let me call those 1 and 8. Now when I cross multiply, I get that 5x plus 8 is equal to 48. The rest is just algebra. What's x? 8. Alright, so we're good up until 12. Now let's take a look at number 13. We have two figures. And it says, find the missing length. The triangles in each pair are similar. I notice that on one of my figures, I have the numbers 39 and x. Which one's smaller? 39? X is smaller? Seems like we have a question. We're not quite sure. Alright, so let me do this real quick. Obviously, for us in class, I can use a string. Let me measure 39. I'm going to use my little string. It's that big. Now x, if you notice, it's a little bit smaller. So I'm going to say 39 is smaller than x. Right, I use a string. You guys can use the edge of a paper. So I'm going to say 39 is smaller than x. For the other figure, we have 13 and 14, right? I think we can agree that 13 is smaller than 14. I'm going to simplify 39 over 13 as 3 over 1. What's x?
Six.
42. If you notice, sometimes we can run into problems, we don't know which one is bigger. Like 39 and x, we were not able to tell. It was a little difficult. So we have the notation here. Notice that for the 39, the letters that we have for 39 are G and H. So if I look at the notation, G and H are the last two letters of the first figure. Make sure you keep that with TS, which are the last two letters of the other figure. So if you notice for TS on the other side is 13, see how 39 and 13, I kept them together in a fraction? So that's how you can tell. If you cannot tell, like obviously I tell you guys measure it if you need to. You can use the edge of a paper. If not, there's a notation as well. And you can use a notation. Alright, any questions up until 16? Yeah. 15? Alright, let's take a look at number 15. I don't have notation here, but I can tell that from one side, my numbers are 6 and x. And I can tell that 6 is smaller than x. If I go straight, I notice that 6 goes with 10, and x, which is the whole side, that goes with 30. So over here, I'm going to write 10 and 30. Cross multiplied, simplified, and everything. If I just write x equals 18, I think you guys can see where I got that from, right? I just simplified sideways, 1 and 3. So x equals 18. Okay. We're good up until 16? Now let's take a look at number 17. The same idea is just that on 17, I'm adding a plus or minus where the x is. So from one of the triangles, my measurements are 18 and 39. We can agree that 18 is smaller than 39. For the other figure to have 12 and 2x plus 6, we can agree that 12 is smaller than 2x plus 6. Cross multiply, simplify. Just don't forget that whenever you cross multiply this way, whatever you have over here at the end, right now we have an 18, right? It could be something else if we simplify. Whatever you have there, multiply to the 2 and multiply to the 6. Right, that's the only difference when we have a plus or minus. I think the rest you can do on that one, so I'll just leave it at that. Right, you can simplify, work it out through. But I'm just going to leave it at that. Any questions up until 20? Now looking at 21, the directions are stated the triangles in each pair are similar. If so, state how you know they are similar and complete the similarity statement. For us to know if they're similar, the only three rules that we use for similarity are side, 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 angle, side, and angle, angle. Remember, angles have to be congruent, sides have to be proportional. Looking at question number 21, I'm already given that angle F with this other corner here, they're the same thing. F and T are the same, right? They were marked to begin with. So I already have one angle per triangle. And then because of vertical angle theorem, I can say that this angle is congruent to this angle. Right? Every time there's an X form opposite angles. So I already have two angles per triangle. Two angles per triangle, that gives me angle, angle. So I have triangle EFG. EFG. I'm going to say it's similar to triangle ETS. Triangle ETS by angle N. Don't forget that the order of the letters does matter. Make sure you do, make sure it is ETS and not something else. Because notice how for one triangle, E and E are the same. That's why I wrote the first angle to be E. Notice how F and T, they're the same. So F and T are the same. Like I said, order matters. And notice how G and S, the order matters. So I was looking at, I didn't give you guys last week's quiz yet. I just caught up on my grading right now. But we had something like this in the last quiz. If instead of ETS, you guys wrote EST, I marked that part wrong. But if you guys wrote angle correct, I will give you half of a point. Because for the two things, you got one right. So make sure order matters. Make sure you get it right. And then for number 24, one thing real quick for number 24. Angle A, I can mark angle A because it is used by both triangles. Right? The little triangle and the big triangle use it, so you can mark it. See how for the little triangle, you have angle A. For the big triangle, you also have angle A, so you can mark it. And if you notice, you have two sides, the angle between, so I will try to go for side angle side, if the sides are proportional. Anything up until 24. Number 24? Okay, so I said I would try to go for side angle side. Looking at one of my triangles, my numbers are 6 and 12. So I know 6 is smaller than 12, so I will just write 6 is smaller than 12. For the other triangle, I have 22 and 44. So I will try, I can cross multiply, but I'm going to simplify first. I can simplify top and down or sideways. I'm going to simplify sideways. I know 6 and 12, that becomes 1 and 2. Sideways, 22 and 44, that becomes 1 and 2. When you cross multiply, you can tell they're the same. So the sides are proportional. So I'm going to complete it by side angle side. So I'm going to say ABC is similar to AST by side angle side. AST by side angle side. Let's see, notice my sides, I made sure they were proportional. And remember, I simplified sideways. Now, let me move into question number 25. In 25, we have 3 right triangles. My screen is showing a big square for the 90 degrees. Oh, there it is. So I do have 3 right triangles. Let me draw them all. And for each right triangle, I have a small side, a medium side, and a large side. Right, the largest of right triangles is always the hypotenuse. So if I look at the small triangle, you guys can see it here. So my small triangle, I'm looking at this triangle. The small side is 36. The medium side, I don't know. But the hypotenuse is x. So I'm going to say the small side is 36, and the hypotenuse is x. Right, from the small triangle. If I look at the medium triangle, which is this one, I only know that this side right here is 64. Right, if the whole thing was 100, part of it is 36, the remaining obviously 64. I don't know the small side, I just know the medium side is 64, and I don't know the hypotenuse. So for the medium triangle, this is all I get. Now, if we look at the entire triangle, right, the big one right here, I can tell that the small side is x, I don't know the medium side, and the hypotenuse is 100. So I have x and 100. I'm not going to use the medium triangle. I'm only going to use the first and third. And the way I want to set it up is 36 is smaller than x, and for the other one, x is smaller than 100. Simplify if you can. In this case, we cannot. So I'm just going to cross multiply. X squared equals 3600. In order for me to get the x by itself, let me do the square root. Square root of 3600 is 60. So x equals 60. Any questions up until 28? Another one? Let me take a look at 26. Before I look at the figure, remember I know that there are 3 right triangles. And I can tell that one of the sides here, this is going to be 16. So if I look at the small triangle, I know the small side is 9, the medium side is x, and I don't know the hypotenuse, so I'm going to set that one up like this. If I look at the medium triangle, I know the small side is x, the medium side is 16, I don't know the hypotenuse, so I'm going to set it up like that. I'm not going to look at the big triangle because I already have enough. I'm going to say 9 is smaller than x, and then x is smaller than 16. Cross multiply, x squared is equal to 144. So x must be equal to 12. Are we good up until 28? Now the last section, 29. For each triangle, make sure you have 2 measurements. I see one triangle have 12 and 9, so I'm good. The other triangle I have an 8, but this little side, I'm going to call it x minus 9. I cannot simplify it anymore, so we're going to have to deal with the x minus 9. From one triangle, my measurements are 9 and 12. For the other triangle, my measurements are x minus 9 and 8. Which one is smaller? X minus 9. So x minus 9 and 8. Cross multiply and you can work it out. 12 over 8, I'm going to call that 3 over 2. Sideways, I can simplify the 3 and the 9 as 3 and 1. When I cross multiply, I get x minus 9 equals 6. So if x minus 9 equals 6, what's x? 15. Good. We work in geometry a lot of solving for equations. In algebra 2, you guys will use those a lot. If you can, later on, once you guys are about to start algebra 2, try to go back to your linear equations. The slope-intercept form, the y equals mx plus b, point slope, things like that that you saw in algebra 1. Try to review those if you guys are going to use those in algebra 2 as well. But solving for equations, you use it a lot as well. Any questions? Number 30? Let me make my figure a little smaller. So I know this little side here is 8. And I know, I look at this as a street. I know x goes to 8 and 15 goes to 10. The way I got the 8, because I knew the whole thing was 18. Part of it is 10, so the remaining part should be 8. So I'm not going to use 18 anymore. From one side I have x and 15. Let me just write x and 15. From the other side I have 8 and 10. Cross multiply and you're good. I'll just leave it at that. You guys can finish it. Just set it up? Okay. Number 31. I can come and say this side is x minus 10, and I know this side right here is 12, but I don't really want to deal with x minus anything, so I'm just going to say from one side I have 10 and x, so I'm just going to set it up, 10 and x. I notice the 10 becomes 8, so there it is. X, which is the whole thing, goes to 20. Then just cross multiply and you're good. So if you do the x minus 10, and so this side is 12, I will set it up the same way. I will just come and say 10x minus 10, and the other one 8 and 12, and no, it will not change. But I recommend the top one just because the x is 5. Okay, any other questions?